Welcome to episode 2 of Layman Conjectures. Today we delve into my take on the topic of the Fermi Paradox. Don't forget to show your appreciation by liking and subscribing to this channel. I have hopes that this small-minded pseudoscientist can share his thoughts with the masses. Of course, always in an effort to spark conversation on these science topics, and others. Let's get started. The title of this essay is A Layman's Speculative Approach to the Fermi Paradox. As I stated in my first writing, a layman's conjecture of dark matter and dark energy resulting from quantum vacuum energy, I am a layman scientist. I have no formal training and lack the mathematical chops to endeavor into the realm of physics or cosmology on a professional level. However, I have a great love of science and strive to push my small mind into these areas and apply my own take to scientific subject matter. Today I posit my own thoughts on the Fermi Paradox. As is often the case with long-held scientific arguments, there are many variables to the Fermi Paradox. My aim is to take a broad approach to disallow the paradox in instances outside the Milky Way. Let's first take a look at the Fermi Paradox. The paradox was birthed in 1950 by physicist Enrico Fermi during a casual conversation at a lunch with colleagues. While discussing the possibilities of extraterrestrial life, Fermi asked, "Where are they?" Knowing there had yet to be any sign or contact of life outside of Earth, this begged the question, why? This notion was later followed up in 1961 by Frank Drake, who created the now famous Drake equation, which attempts to quantify the existence of alien intelligent life. In 1975, Michael Hart, with later contributions from Frank Doppler, extended the Fermi paradox by providing published scientific analysis. The paradox initially posits 4 main points. 1. There are billions of sun-like stars in our galaxy, many of them older than our own. 2. Many of these solar systems have Earth-like planets and some may have intelligent life. 3. Some of this life may have developed interstellar travel, or communications. 4. Civilizations with interstellar travel would likely be able to travel the Milky Way in just millions of years. The paradox has become a philosophical exercise attempting to explain why we have not yet seen evidence of intelligent species outside of our home world. The explanations range from shy aliens, to great filters that prevent civilizations from reaching an interstellar level. While these explanations can be fun to hypothesize and utilize as thought experiments, they only suit to presume why we have not been contacted, or never will be. I don't agree. I want to focus on what has been done on an empirical level and show you, dear reader, why we just don't have the information we need to answer whether we are alone. Our main tools for seeking out alien life has, and continues to be, visual and radio astronomy. Organizations like SETI and professional and amateur astronomers have been pointing their instruments into space for decades looking for a signal from the heavens, or a sight that would indicate that we are sharing our universe. But alas, we have found nothing. Current logic tells us that we should have discovered some aspect of intelligent life, whether that be distant K2, that is to say, Kardashev level 2, surrounded by a Dyson sphere, or perhaps even a Matryoshka brain. Or in the very least we should have spotted a von Neumann probe taking a look at our own system as it explored the galaxy. In fact, in recent times we saw many get excited that our newest interstellar visitor Oumuamua could in fact be an alien probe. While this is still not unproven, it is unfortunately quite unlikely. Is this lack of evidence proof that we are alone in the universe? I firmly doubt it. I would venture to say that it shows it may be less likely when we look at the Milky Way, but not impossible. At 100,000 light-years across there is still time for other civilizations to make themselves known to humanity. The problem is one of distance. I think we can almost safely say there are no advanced civilizations, at our level or higher, in our neck of the Milky Way. But we cannot be as sure the further we move out. As we look farther away, we know we are looking farther back in time. Meaning if we are looking at a system 50,000 light-years away on the other side of the galaxy, we are seeing what it looked like 50,000 years ago. What if another civilization is on equal footing with us? we would not be able to see their radio signals for another 50,000 years. Why must we assume that they had a greater head start? Might they be slightly behind, or ahead for that matter? In any of these cases there may be neighbors we are just waiting to be contacted by, as our signals travel the galaxy. Thus, we can never say, no, to the possibility of intelligent life in our galactic neighborhood. Where the Fermi Paradox breaks down the most is with even longer distances and varied galactic timelines. Looking at the Andromeda Galaxy, for example, we see that it is a full one-third younger than the Milky Way at only 10.1 billion years old. The Milky Way is 13.51 billion years old, and at a distance of 2.5 million light-years we are seeing Andromeda at only 9.85 billion years old. And while it has over twice the amount of stars as the Milky Way, it has had less time for civilizations to form. But assuming a civilization was lucky enough to form earlier in its galactic life and even a million years ago on our time scale, we will not see a broadcasted message from them for another 1.5 million years. Andromeda is a close neighbor in our own little galactic cluster, but we have sought the heavens even further for civilizations. But as in the case of Andromeda, I feel that we are wasting energy. As we look further and further out into the great expanse of space, the ages of the galaxies we see are younger and younger, making the likelihood of seeing intergalactic, or even interstellar, civilizations next to impossible. Many arguments I have heard point to the fact that we should see heat signatures from Dyson spheres, or even perhaps voids in the sky where K3 civilizations have mastered their entire galaxy. I don't deny that this may happen one day, or perhaps is happening now or in the past by older societies. The issue is that due to the distance we will likely never see them. As the time it would take to achieve such civilizations just has not happened in terms of distance over visible time when looking at our current expansion model of the universe. We have to keep in mind that the universe, at the time of this writing, is 13.8 billion years old. I have to be concise as I am sure that this paper will be required reading for eons to come. So let's use the oldest visible galaxy to illustrate a point. GNZ11 is 13.4 billion light-years away. That means we are seeing this galaxy when the universe was a mere 400,000 years old. And let's assume that an advanced civilization popped into existence in merely 1 billion years. This would be a dramatic feat as it took Earth 4.5 billion years to just create pesky humans. But even assuming this miracle, it would be another billion years before we would see it. And that galaxy has had an additional 13.4 billion years to develop advanced civilizations since. So, just because we can't see it looking up at it now, doesn't mean it isn't there. As you can see, the Fermi Paradox, while a good thought experiment for relatively close observations, does not hold serve for distant objects. Looking out to great distances, i.e. time, only tells us that there were no civilizations, that long ago, not, that we are alone now. I suggest that life is not uncommon and that the universe is seeded with multitudes of intelligent life, just waiting to make contact as we are. I defy anyone to prove otherwise to me. Until then I will take it on faith that one day, perhaps millions, or even billions, of years from now we will get that signal. Then we will have to start a new debate. Asking ourselves, are they, still, there? If, we indeed, capture a signal a million years from now from a galaxy even 5 million light-years away, the new question would be, have they survived since they sent the signal 5 million years ago? How advanced have they become since they sent the signal, and, have they mastered time travel, perhaps? In that case, are they already here, or have they been here for a while? Or in a sadder case, have they long since become extinct? Unfortunately, these questions, like those first posited, will likely always just be thought experiments as the distances involved make actual contact, or better put, communication, very unlikely in our, ever-expanding, universe. What are your thoughts on this subject? Do you think we have it all wrong? Am I, in my limited knowledge, spewing nonsense? Let me know in the comments below. And, until next time, remember the words of Albert Einstein when he said, "Imagination is more important than knowledge." They're both important, but knowledge without imagination is barren. It is my hope that these papers, sharing my own thoughts, spark the imagination of others, to take the work forward and beyond current understanding. Until next time, keep thinking.